Okay, so a while ago someone asked me to do the switch problem, so let's do it. I don't like this problem, but I guess maybe some good can come from it. The part that I don't like is you look at this witch, and this witch is holding a wand and holding a broom. So then you have to figure out what it means for a witch to hold a wand and a broom, and then this one, no wand, no broom. So how much is the value of a witch of itself? And does it mean addition? Does it mean subtraction? Does it mean, I guess you can narrow it down to addition or multiplication, what it means for a witch to hold a wand. So, I guess that part's kind of mathy, right? So we've already seen, so I guess, and I guess there's one more. This one right there is actually a double broom, two brooms side by side. And this one right here, I guess, is a double star, two stars side by side. Although maybe, and I'll tell you why. I guess what I want to say is the witch, right, holding a broom. That right there, I'm pretty sure is equal to star plus witch plus broom. The reason I say that is because we've already seen what multiplication looks like geometrically. If we have, let's say, 2 times 3, and we have something that's of length 2 multiplied by something of length 3, that's going to give us an area of 6. 1, 2, 3. My comma's off, but well. So this is what line segment 2 times line segment 3 should look like. It should look like 6 squares. 2, 3, 4, 5, 6. Furthermore, you can extend this into shapes. So instead of a line segment 2 and a line segment 3, we could look at what would be like a circle times a circle. Well, if you'll note, at every point along here, we had to go too high, too high, too high, too high, too high. So we could say at every point along a circle, we'd have to draw another circle. So instead of too high, we're drawing another circle. So another circle, another circle, another circle, another circle, another circle, and then connecting all those circles together in one continuous pattern. You're going to get something that I like to study. You get a torus. You get an empty donut. So you could say a circle times a circle is going to equal the surface of a donut. So we know what multiplication of shapes looks like. So if it was like broom times a witch person, then at every point along the broom, you would have to have a witch person, and then the witch, just like we did with the surface of the donut. And then all these witch people would be connected in one continuous witch person type of, well, let me try and draw their arms sideways so that way you can get a better effect of what that might look like. Meow, meow, until you get to this point. And then at that point, all of these strands would all have a witch person on top of them. So that's clearly not the picture we have. That's clearly not the picture we have here. So that's why I'm saying which person holding a wand and a broom must be addition. It's probably not multiplication because we know what multiplication of shapes is like. This one right here is probably also two brooms side by side. This wand could go either way because we know what happens when you multiply by a number. Multiplying by a number is like geometrically extending it by a line segment. I think what they meant, right? I mean, they mean like wand plus wand, right? But if you want to get picky, I mean, which apparently a picture that hides brooms in people's hands is trying to trick you. If you did wand, first off, if you did 2 times 1, that's equal to 2. And geometrically, that would be if you had 2 along here, 1, 2, and then you multiplied it by 1, you get the same number of squares, 1, 2, right? And this height is 1. You get 2 squares. In fact, anything like 1 is what's known as a multiplicative identity. So like 327 times 1 is 327. And then you only go one high here, and you get 1, 2, 3, 4, to 327. So when you multiply by 1, you get the same number back. So who's to say maybe this is wand times 1, maybe. But I think what they wanted was wand plus wand. So let us do this the way that they wanted us to do it. We're going to just do this regular old algebra. I'm going to use a W for the which person. I'm going to use an S for the star, wand. I'm going to use the B for the broom. And I'm going to label these lines 1, 2, 3. And the goal is find broom plus which times star plus star, which is the same as 2 star. So we can rewrite this as the goal is to find broom plus 2 star wand. Alrighty, that's our goal. So that first line tells us that we get 3 of the exact same thing, and adding 3 of the same thing is multiplying by 3. And what are we multiplying by 3? We're multiplying wand, which person, broom. So star plus which person plus broom, and that's going to have to equal a 45. 45 is 3 times is equal to 3 times 15. So then we know that star plus which person plus broom has to equal 15. Number 2. 3 stars. We can either, which I'm S for stars. We can either star plus star plus star, and that's equal to 21. That's the same as saying 3 stars is equal to 21. That's the same as saying star must equal a 7. So now we can revisit equation 1 and substitute our star back in. Star plus a wand plus a broom, or which person, has to be a 15. Subtract 7, subtract 7. we get wand plus, or which person plus broom. If I have these stupid problems, or 8. The last one is we get 1 broom, killing me, 1 broom plus 2 brooms plus 1 broom. So I guess it's 4 brooms total. So 4 brooms total is going to equal 12. So 3, we get 4 brooms is equal to 12. Then you know that the broom has to be 3. You just divide 4 on each side, right? That's how I'm doing these so quickly. I don't know if people caught that. Whatever you do to one side, you do to the other, as long as you're not dividing by 0. You get a 3 right there. So then we know, revisiting number 1 again, which person plus 3 has to be 8. Subtract 3 from both sides. We know which person must be a 5. Now we can get our goal. Stated goal was, what is broom plus 2SW? So goal. Broom plus 2SW has to equal, we know broom is 3. 3 plus 2 times our star wand was a 7. 7 times 5. In order of operations, you do multiplication first. So this is 3 plus 70. So we get a 73. Woo woo. It's important to follow the order of operations. This is one of those examples, like if you did 3 plus 2 first, that's going to equal 5. And 5 times 5 times 7 is going to be 25 times 7. And if you have 7 quarters, that's, what is that? $1.75. So that's 175. So you could be off by quite a bit if you do not follow our order of operations. This would be wrong answer. And this one, totally right. Right. So you would do parentheses first, then exponents and powers, you do those equally. Multiplication and division, you do those equally. Not one is not better than the other. And then addition, subtraction. That's the order of operations. Answer. Wrong answer. Alrighty.